Welcome to Easy Elim Learning Simplified. My name is Ruth, and today we are going to be discussing on the topic simple classification of substances. And we are going to be looking at the kinetic theory and specifically heating and cooling of substances. Initially, we talked about the heating curve and we looked at the heating curve and different regions in the heating curve. So you can go back into the previous lessons and check that out and see how you can be able to explain heating curve confidently. So for today, we are going to look at the cooling curve, and then also we are going to discuss that data and the regions or whatever is happening in the particles of each region. And we are going to relate it also to the kinetic theory of matter that we discussed in the previous lessons. You can also check this out in the other lessons that we have that are in the system. And then also, we are also going to look at one question in regards to what we are going to be discussing. So, previously we talked about heating ice. So, today we are going to start with gaseous water or steam. And then we are also going to end up with our previous ice that we had discussed in the previous lesson. So we can see our steam is starting at 100 degrees Celsius, and then it cools down up to negative 40 degrees Celsius at point F. So let's look at each region and what happens in each region. So when we look at point A, B, or region A, B, first of all, we are working with a gas. Here, the state here is gas. It's gaseous in state. So remember we said for the gaseous particles, they're usually further apart. They can move about comfortably from one place to the other. There are no forces between the gas particles. So we are working with particles that are moving randomly and further apart, not together. So the first thing you notice in region AB is that temperature is decreasing. That's the first thing we said, even as we were discussing on the heating curve. And then when the temperature decreases, then our kinetic energy is also decreasing. So we are losing heat into the environment. We are losing that heat. The energy is also decreasing. So also the movement of the molecule decreases. The movement decreases. So they stop moving randomly and faster like they were moving before. They start moving slowly with no energy. And then in region B, C, you can see clearly the first thing is that the temperature is constant. That's the first thing. The temperature is constant. So the temperature is constant. Why is the temperature constant? Because first of all, the heat is being lost in this system. So the particles are coming together. They are coming together. Slowly by slowly, they are coming together. And when they come together, it means that the bonds are beginning to form. They start like attracting each other because of the closeness of the particles. So we say that when this happens, the gaseous particles turn into liquid. So when we start at point B, all the particles are in gaseous state. As we move on, the particles begin to come together to turn to liquid. Slowly by slowly, as the temperature continues to be constant. By the time we get to point C, all the gas particles have changed into a liquid. So that is what happens in region BC. So let's go to region CD. So in region CD, the first thing we notice is that the temperature decreases. We always start with the temperature. So temperature is decreasing. So the moment the temperature decreases, we are losing heat into the system. So the moment the heat is lost, it means the kinetic energy is also decreasing. There's not enough energy in these particles. The particles are losing energy. They can't move as fast as they were moving before. So the movement also decreases gradually. If they were close together, they start even coming more close. So you see the energy has reduced. So remember, temperature affects the kinetic energy. And then we go to region DE. So the first thing you notice is that the temperature remains constant. So when the temperature remains constant, initially we lost some heat. So the heat that is being lost makes the particles to come even more closer because they do not have the energy to move. When they come together, they form a bond. So this bond makes it to like be attracted very closely, and the liquid changes to a solid. So when we start at this, we are starting with all the particles as liquid state. But as we move across, like as time passes, you notice some of the liquid turning into solid. By the time we get to point D, all the liquid particles have turned into a solid. So at point E, we are working with solid particles. And then finally, we look at region E and F. So the first thing you notice is that temperature decreases, as we said before. If the temperature is decreasing, we are losing heat, goes hand in hand. If we are losing heat, it means that the particles are not even moving at this state now. They have come together. Remember, they're in solid state. They have come together. They have attracted each other. Now our particles are in solid state, as you can see. So that is the explanation of how a cooling curve happens. You can be told to explain a certain region, can be picked even from an excerpt, and then you are told to explain it. So you should be able to explain. Remember, we start with temperature, which affects the energy, either lost or gained, and then which affects kinetic energy, which is increases or decreases. And the moment particles don't have energy, their movement begins to decrease. So remember, the attraction between particles also matters in explaining which states they are in. So next, let's identify the processes happening in these graphs and also identifying the states in each region. So we'll start with the processes and states. So at region AB, we said that this water is in gaseous state, it's steam in gaseous state. When it gets to point B, it starts turning into liquid. So we do not have a specific state of matter, it's a mixture because the process is happening continuously for some time. So the mixture will be in gaseous state and also some liquid will be in this region. And the process of changing from gas into liquid, we call it condensation. Condensation. And then in region CD, the state is liquid. It has already turned into liquid, as you can see from the previous region. And then there's no process happening in CD. But when we get to DE, the temperature is constant. So some of the liquid particles are changing into gas slowly. So the state will be liquid and solid because it's changing slowly with time. So that by the time we get to point E, all the liquid particles have turned into solid. So the process here, we call it freezing. And then from region E and F, the state will be solid. It has now turned into a solid. So let's look at one sample question in regards to what we have discussed. The graph below is a cooling curve for water. Study it and answer the questions that follow. So we have the water. We are starting with it at 100 degrees Celsius. So it's not in gaseous state, it's actually in liquid state. And then we have move up to point E. So explain what happens to the molecules of water in region BC in terms of kinetic theory. So if you look at the graph, automatically the first thing you notice is that the temperature decreases. So the temperature decreases, and we said if the temperature decreases, also the heat is lost, and this causes the kinetic energy to decrease. If the kinetic energy decreases, then the particles move slowly. These particles move slowly. So this is what is happening at region BC. Temperature decreases, heat is lost, kinetic energy decreases, and then the particles move very, very slowly. And then finally, in what state is the water in region DE? So in region DE, remember here it's in liquid state. So in CD, it's turning from liquid to gas. So region DE is already turned into solid state. So that is the state in region DE. So that's it for the cooling cap. I hope you have been able to understand like each and every region, what happens in each region, and you can be able to explain comfortably. The key thing is to identify the things that are happening that you can see in the graph, which is the most common is the temperature decreases. And the moment the temperature decreases, it affects so many other things in the particle. So the heat is usually lost and then kinetic energy decreases. And depending on the state that you are in, the particles are going to move slowly and there's a change in the state of matter that is going to occur. So it is good to be able to know how to explain this process comfortably. So that's it for today. We are going to meet in the next lesson.